speaking about radiation on the lunar surface, we have Mr. Leigh Whicker here today, who is the commercial manager of entX. So Leigh, welcome to the desk. It's great to have you here.
Thanks very much. It's great to be here. It's great to sponsor such a fantastic initiative, and seeing students see that there's career pathways for what they're doing at university, and the future of lunar occupation and exploration.
Absolutely, and if you don't mind, we've got a few questions for you here and some of the work that you do at entX. So for those that don't know, entX are developing solutions that have direct application to rovers and other technologies looking to operate in space, and of course on the lunar surface. So could you tell the audience a bit more about how your technologies will help support space operations, especially if we're looking to survive the lunar nights and some of those deep space temperatures?
Yeah, so for those that don't know, entX Limited is a company based in Adelaide. We've got a capability in nuclear engineering, material science and advanced manufacturing. And what we do with isotopes, we say we put them in situations of value. So two parts of the business. One's a nuclear medicine business, which is supply chains of isotopes into manufacture of radiopharmaceuticals. And the other side of it is space and defence. So we're developing technologies primarily around energy generation, but taking the energy from isotopes and putting them into situations where we're using them for generation of power and generation of heat.
That's a really interesting crossover there with the medical world and the space world. And, Adelaide University has worked together with entX for a number of years. And more broadly, the company has partners and collaborators across the world, some really, really interesting partners. Thinking specifically about research institutions, what are the benefits you see in creating an ecosystem where entX works with a wide range of researchers, technical teams and students across all these different fields?
Yeah, so we've worked with both University of Adelaide and University of South Australia. Some of our early work was done in the Future Industries Institute. So Drew Evans and his team have been instrumental in helping us set up manufacturing processes that are industry relevant. So that's super important for us. I also met John Colton shortly after he was made the director of the Centre of Space Resources.
Yeah.
And I was doing some consulting work with entX at the time, and I tabled a few of these concepts that we were doing. He said, "Oh, these are exactly the types of projects that the uni wants to get involved in." So, yeah, we've had a really good, relationship with both universities. Now, obviously, the merger is something pretty exciting as well. But it's these quality partnerships that help us, do things like get grant applications and, to a degree, help us raise capital. So we see it's a super important thing. The industry relevance piece is super important as well. Also, as I mentioned before, giving students the view that there are career pathways and there are companies like ours that are developing technologies. And for an example, our radioisotope heating unit, we're going to space with that at the end of the year. So these things are happening. So it's super important the work that the guys are doing out here today. They understand that is relevant for what's to come.
That's incredibly exciting, and to have a space-qualified radioisotope heating unit like that, that'll be amazing going forward for developing those future technologies, especially for the lunar surface and beyond. We've talked a lot today about lunar habitation, and a massive thing that will need to survive is power and heating, and yeah, it's incredibly exciting. So I guess that leads into our last question, which is, if you're looking under the hood of any one of these rovers, you'll see the results of, months, if not years, for some teams of development. So, as a company that has innovation really at its core, are there any final thoughts or words of advice you want to share to the teams?
Well, I think what's important here, and I know there's a bit of competitive spirit here, which is great, right? But I think the team should really be proud in the fact that they've actually been able to form a team with the capabilities required and get something out here actually competing. I think that in itself is a win, because don't sort of underestimate the effort it goes, or companies need to go to actually find those teams and get those capabilities to an end solution, what's happening out here today. So I think every team has won in a sense by actually getting out here and showcasing what they're able to do. If you win, it's a bonus, but that's probably one of the things. And I think another side of it, I also always say to young engineers, is that there is that technical element, to designing all these things, but don't lose sight of the fact that, it's got to be a commercial, feasible outcome as well. So, I mean, anyone can design a Ferrari with finite resources and that, but only the really good ones can design a Ferrari that is on a budget and a timeline. So don't forget that commercial aspect in all of this as well, because that's what will drive getting project finance or raising capital, is that the people can see it's got a commercially feasible and there's an outcome at the end of it. So.
Absolutely, and working with all those constraints of the real world to make it commercially viable. Well, thank you so much for joining us here at the desk, Leigh. And yeah, if you want to know more about entX, definitely look up online as some of their missions coming up. It's very exciting work. So, and all here in Adelaide, South Australia as well. It's amazing to have this at our doorstep. So thank you so much for joining us, and we'll go back to the field.